Okay, in this tutorial we're going to have a little look at L'Hopital's rule and how it can be used to help us find the limits of functions of the form either 0 over 0 or infinity over infinity. Now if we've got a function which we find is of that form, then we can use L'Hopital's rule. To give an example of the type of function I mean, if we look at the limit as x approaches 0 of 1 minus cos x over x squared. If we just plug 0 straight in, we'll get 1 minus 1, which is 0 over 0. So that is of the form 0 over 0. Now what L'Hopital's rule states is that the limit will be the same if you independently take the derivative of the top and bottom, not of the whole function. It's important to stress this. Okay, so it's function f prime of x over f prime, sorry, over g prime of x, okay, where in this case f of x equals 1 minus cos x and g of x equals x squared. So to put that a bit more bluntly, what it's saying is the limit as x approaches some variable which makes 0 over 0 or x over x of f of x over g of x equals limit, or as x approaches that same variable of f prime x over g prime of x. So basically what it's telling us is we can take the derivative top and bottom until we no longer get 0 over 0 or infinity over infinity. Okay, that being said, let's work out our example. Okay, so if we just get rid of all this here, and we just bear in mind this rule here, we just take the derivative top and bottom. So the derivative of the top is going to be cos x differentiates to minus sine, it's already a minus, so then we get sine x on the top and we get 2x on the bottom. Now in this case we get 1 over 0. So it's still divided by 0, we can't do that. So what we can do is we can apply L'Hopital's rule again. So if we take the derivative top and bottom, we get cos x over 2. Okay, it's no longer divided by 0, so even if we get 0 on the top, it's still valid now, because we're no longer divided by 0. It's no longer undefined. So if we just plug in our limit as x approaches 0, we get 1 over 2, which is correct. That is our limit. So we know that now equals 1 over 2. Okay. And if we sketch this graph, it's a sine over graph, it's decreasing and increasing with respect to x. So we'll get something that looks like vaguely like this. Something like that, and we know the limit here as x approaches 0 is going to be 1/2. Okay, it's just a rough graph just to show you contextually this example. That is meant to be even both sides, but that's by the by. We're just interested in the limit of the function here. So, hope you found this tutorial useful. If you have, give us a like, and if you've got any questions, leave a comment. And of course, if you want to keep up to date with our videos, don't forget to hit that subscribe button. It really helps. Thanks for watching.